Okay. So focusing on this video, so actually today we will be learning derivatives. And previously last week, we learned something about limits. Okay. And now we will see the connection of the limits going to derivatives. Please take note that the derivatives, the concept of derivatives originated from the concept of limits. Okay. And this is presented through this video. We have this formula. Actually, when we say derivatives, this is the limit of a difference of quotient. And this is actually the formula that's being used to evaluate the derivative of the function. When we say derivative, actually, we are finding of the slope of the tangent line to a certain curve. Huh? What's that? Let's have this as an example. Okay. Assuming we have here, okay. Wait. But ayaw niyang kumonek? Okay. Ito. Assuming we have here, sorry. Something happened to my pen. Okay. So actually, when we say derivatives, we have this function, for example, a quadratic function f of x, and there is this certain curve, or there is this certain tangent line that intersects our given curve at that point. So the slope that we will be using to identify that the value of that point is called the derivatives of the given function. So rate of change, we are talking about the rate of change in learning these derivatives. Okay, now let's have this as an example. So for example, we have here, let's try f of x. Siyempre, yung madali lang muna. We have f of x is equal to 3x squared. Okay, this is our function. And we are asked to find the slope of the line tangent to the curve at any point x. When you say any point, in short, dito gagamitin natin yung limits natin. So in here, what was presented a while ago in the introductory video was the longer process. And actually, there's a shorter process for that one. And that is this. If we are not yet directed towards the value of x in our given limit, for example, in here, as z approaches x, so that is what we mean by letter A. So we are finding the slope now of the line tangent to the curve at any point x. So in short, wala pang specific value si x. What we are finding now is the slope of the tangent line that will intersect to a given curve. At eto, this function, when we graph it, this is the curve that we are referring to. Okay? Now, how is this done? This is just actually very simple. In the video a while ago, that's actually the longer process, and this is actually the shorter process. Ito yung mas madaling paraan. Okay? So, to solve this, all we have to do is to identify our function, and our function here is 3x squared. So the 3x squared will be our f of x. Ayun. In here, this f of x will be 3x squared. Can you follow? But we also have here this f of z. And when we say f of z, all we have to do, whatever is the variable of our function, we just have to change it to z. So we will be changing our variables to z. So f of x is 3x squared, and f of z will become, f of z will be equal to whatever this is, we will copy it, 3, but just change our x with z. Z squared. Okay? And then z and x are just the variable for z, and x is the variable for that x squared. Okay? That's it. And all we have to do now is to substitute in our given formula. So how is this? So this becomes, again, derivatives is actually the slope of the tangent line to the curve. Remember that. Derivatives is the slope of the line, the tangent line to the curve. Tandaan po yun. So we now have here m is equal to the limit of, as z approaches x, the limit of, this time we will be substituting all these values. F of z, this is it. This is 3z squared. Okay. And then in here we have minus, our f of x is 3x squared. Can you follow? And then all we have to do is to just copy z minus x. Okay. Now let's solve this further. We will now have m is equal to the limit of, this time let's simplify this, but let's factor out the common, which is 3. Common si 3, so we will factor that out. So we will have 3 times, what's left inside will be z squared minus x squared. Can you follow? And then just copy z minus x. Z minus x. Okay? Next, let's solve this further. As you have noticed, this is actually difference of two squares. So this can be factored. So to continue, we will have m is equal to the limit of, as z approaches x, the limit of 3. Factor this difference of two squares. We will have, just copy everything. Let's factor this out. Z squared, that becomes z and z. X squared becomes x and x. This is plus, and this is minus. Can you follow? And so, after that, all we have to do is to simplify this. We have here z minus x and z minus x. So we are now left with m is equal to the limit of 3 times z plus x, as z approaches x. Okay? Can you follow? Now, to evaluate the limit, after that, we have to evaluate the limit. And how do we evaluate the limit? We simply substitute the value of our z to whatever value it is approaching. And this times this is x. So that's what we will be substituting here. So when we evaluate the limit, we will just have m. And when we evaluate, remember the limit symbol will already be removed. So that becomes 3 times, change z to its value, which is x, and then continue, plus x. Can you follow? So we change that. Ayun. This actually came from, sorry, it's not z. It's actually x. This actually came from this. Kaya siya naging x. Can you follow? That's because we already evaluated our limit. So in the end, we will have here m is equal to 3 times x plus x times 2x. And actually, our m here, our slope, the slope of the tangent line to the given curve, the function is m is equal to 6x. That is the process of finding the slope of the tangent line to the given curve, which is 3x squared. Can you follow? Show me a reaction if you were able to follow that process. Okay, what we're doing here is we're finding the connection of the limits to derivatives. Okay, now after that, remember, the derivatives is the slope. Remember, it's the slope of the given tangent line to the given curve. And that curve is the function. Okay, that's it. So we now got our slope, which is 6x. In letter B, we are asked to identify the slope at the point where x is equal to 2. In this case, we are now going to find the specific value of the slope, wherein x in our Cartesian plane, the x value will be 2. Anong value kaya ng slope ang magagamit natin? So this will become, just substitute for our letter B, m is equal to 6x. That's our slope formula. And x is equal to 2. So let's substitute. M is equal to 6 times 2. So our slope will be 12. Since rise over run yan, when we graph this, this is actually 12 over 1. Okay? So that is the slope. That is the value of the slope when x is equal to 2. Can you follow? Show me a reaction if that's clear to you so far. Following the process, let me see if the process is clear. Very good. Okay. Now let's try to graph this. Let's identify the graph. Let's have here. Okay. Graph. Okay, let's graph f of x is equal to 3x squared. Ayan. F of x is equal to 3x squared. Ayun, that's a curve. Did you notice that? Ayan. And so, let's get this. Liitin pa natin ng konti. Kailangan lumabas yung kailangan lumabas nung value natin for x. Ayan, ito na lang. There. So, I'll take a screenshot of this. This is just for you to understand what is this derivative all about. Okay. So, having this, let me just put it here. And that is the curve, or that is the graph of our f of x, which is 3x squared. Can you follow? And at a certain point, x is equal to 2. Look at this. This is our x. This is our x coordinate. No, x-axis. So dito natin hahanapin yung x is equal to 2. Ayun. At x equals 2, there. Dito sa point na to, saan kaya magta-touch yung tangent line? And as you can see in here, that is 12. If we will be drawing our tangent line here, let me just do this. At 12, m is equal to 12. If x is 2, dapat nandito siya sa 12. Doon siya dapat magta-touch yung tangent line natin. There. I hope you can imagine. Yan. So, let me just draw this. There you go. That's the tangent line. Okay, and doon sa mismong 12 na yon, nag-intersect yung ating tangent sa curve. So that is the value wherein we are looking that we are looking for in this problem. Kaya nga, if you will look at this, In here, the rate of change, the slope actually is rise over run, just like what I told you a while ago. That's m is equal to 12 over 1. So from here, look at this. I will make this bigger. Ayun. So looking at this part from this point, that's 1 actually kasi 2 points yung ating counting. 2, 4, 6. So this is 0. This is 1. 2. This is kalahati is 3. 4. Kalahati is 5, etc. So following the concept of the slope, just like what I told you, that is actually 12 over 1. Ayan. So from here, let's verify if it's really 12 over 1 by following this. So from here, that's 2, 4, 6, 8, 10, 12. At exactly this point, 12, that's the rise. That's 12 over 1. That's our slope a while ago. This is rise, just following our rise over run process. They are both positive, so therefore ito ay pataas. Run, positive, it's going to the right. So from here, we are now here. Let's move 1 point going to the right. 1. So we got that point. We're in. That's the point of tangency. We're in. Our tangent line intersected our given curve. So that is the concept of derivative. Can you follow? Show me a reaction if the concept or the connection from limits to derivative is clear to you. Let me see. Show me a reaction, please. So now with this, actually I can just simply go on and show you the derivatives formulas. But at least with this one, you know that it's not just a simple derivative rules or derivative formulas, but actually it came from the concept of the limits, finding the slope of the given tangent line to the given curve. Can you follow? That's it. Thank you so much. Now, did you know? At sabi ko nga sa inyo kanina, what do you want? Mahirap yung madali agad or yung mahaba muna? It's a good thing that your classmates requested for that long process muna para makita yung difference ng dalawa at yung connection ng limits sa derivatives. And now, let's move on to the most exciting part, the derivatives. Did you know, class, that this process, this long process using our limits can just be simplified in just one step? The derivatives of this function can be taken just by one step and not actually doing this long process. Do you want to learn that? Show me a reaction if you want to learn that. Let me see. Okay. Okay. O, ganito lang siya kasimple. Did you know that? If we will just be getting the derivative of this, the f of x, this is the function pa, is equal to 3x squared. To show its derivative, actually this is a slope. To show the derivative, it's just putting an apostrophe, f prime x. Kapag ganito, derivatives na yung sinosolve natin. Is equal to, if we are given this term, this is just very simple. Take note of this. Whatever is your exponent, multiply it by your whole number, your coefficient. So 3 times 2, that becomes 6. Can you follow? And then copy your variable, which is x. And the next thing to do is to reduce 1 in your exponent. So 2 minus 1, that becomes 1. And if the exponent is 1, there's no need for us to write it anymore. So that's it. The answer here, the derivative is actually 6x. That's the simple step of that long process. Show me a reaction if you love that derivative process. Yun na yun. Finish. What? Okay. Gets na? Ganun lang siya kasimple. Okay, that's derivative. So what do you want? Finding the slope using limits or using the derivatives? Type your answer in the chat box, please. Very good. Thank you. Yes. Derivatives is easier.